So, I guess jumping off of the Pebble talk with everything being in JavaScript, we're going to be doing another talk in JavaScript, particularly about an idea called composition. Although everything in this presentation is in JavaScript, this is much more of not completely language agnostic talk, but it's going to be covering more like abstract design patterns. So if you're a Ruby developer or a Java developer or anything, you could probably take something from this. So my name is Christopher McLean. I am a software engineer here in Orlando, working mostly in Ruby, JavaScript, and Sass. Occasionally I'll jump into other languages if the project calls for it, but this is mostly my bread and butter. Done some talks at the University Tech Meetup, never allowed to do JavaScript, so I'm actually really excited.
All right, I got it.
Not letting you live that down.
No, you're not.
But I don't think it would be a good JavaScript talk in 2016 without talking about ES6. So back in June, at least I'm going to, I think it's June, I could be wrong here. I believe back in June, the standard for ES6 was finally developed into some sort of cohesive standard, and developers across the country rejoice we have classes. I don't know why I'm using this if I'm just going to...
It's recording.
Oh, it's recording?
Yeah.
All right, sorry people watching.
Or they will watch later.
Oh, you have fans.
All right, so... Okay, so we have class... Okay. So, continuing. JavaScript has classes.
But those girls don't.
David at your finest.
Which means we can now do things like this. And if you've ever taken any Introduction to Programming course or Object-Oriented 101 course, this should look somewhat familiar. It's sort of like the classic welcome to object-oriented example. And it's what we call single inheritance or classical inheritance. And it's what a lot of new developers, when they're getting into object-oriented programming, take with them throughout their career as a programmer, which is a little unfortunate because there's many different ways to approach inheritance in programming, or at least the effect of inheritance in code reuse and introducing new functionality to your classes. And this is just a few. I'm probably missing a good number of them up here. And if anyone out there is a JavaScript programmer, the word prototype should stand out to you a little bit. But we're going to be talking mostly about that last item, which is composition. So object composition and what it is. Put very simply, you have an object. That object takes in a bunch of other objects and tells those objects how to work together. It is teamwork in object-oriented programming. And it's very useful if you want to make more complex machines. The example I always like to turn to is the example of a bicycle. Because trying to make a bicycle in single inheritance is very, very, very difficult, and you probably shouldn't do it. And this is because a bicycle is made of many different tiny parts. And there's a lot that goes behind trying to simulate an actual bicycle or any other complex machine. For example, you might have a brake system that needs to tell the tires to stop spinning. But if this brake system's on and you're forcing the tires to spin, there might be damage to the bike. I mean, there's a lot of communication that has to go on behind the state of this machine. And this is sort of where this pattern comes in. And the code, at least getting started and just wrapping your head around the idea, isn't all that scary. You just basically have a class with some sort of constructor function that takes in any number of objects. We don't really care what type they are, just that they act like the thing that our variables describe, because there might be any number of different types of tires and wheels and et cetera, et cetera. And all of the methods which I did not put in this example would tell all these different parts how to work. Maybe you just have a single method called ride, and it orchestrates all these parts to make your bike go forward or move a coordinate somewhere on a map. So why am I doing this in JavaScript? Particularly in JavaScript, I think this is a pattern that's starting to get a lot of traction and isn't really being taught as a formal concept. We're seeing it come out of a lot of the newer frameworks, especially in the form of a lot of different web components. And I would say that JavaScript is made up of a lot of well, a lot of the libraries in JavaScript revolve around manipulating tiny objects. And like so. I would say most of the common libraries we use from day to day, like the Canvas API and just native JavaScript, or D3, which is built around graphing. All of these different libraries that we use consistently in JavaScript work around just orchestrating tiny objects to make this, I guess, more complex machine like a graph or an HTML5 Canvas game. And a lot of the web component frameworks and more, I guess, quote-unquote MVC frameworks are adopting this as well. So trying to understand this as a formal concept might help you understand a little bit more of what the developer's trying to do, and I guess spend less time stressing over the fact that they've, decided we're not going to do Angular 1 anymore and completely change frameworks with Angular 2. So, but it's not just for frameworks. It's not just for any of the libraries. You can do a lot of this in just plain ES6. And this is where I start to get into some of, I guess, the advertised audio visualization stuff. Because all the code I'm about to show from this point forward is going toward building a single project that I did in ES6 and React, which I'll show off toward the end of the project. End of this presentation, I'm sorry. So this is an example of composition via some sort of service class, some sort of just basic ES6 class. And this is built around a native part of JavaScript that doesn't get talked about a lot, which is the audio API. And if you've ever touched the audio API in JavaScript, it is enormous. And if you know nothing about audio, it's a real pain in the ass. Which is why I wanted to wrap it in some sort of class and just forget that it exists. But it's a good case for this kind of pattern. When we work with audio, we don't really care about all these tiny little things that make up an audio stream. We just care that audio is moving from one place to another, and we want to keep track of the data. We don't really care what a context is, or where our audio source comes from, depending on which browser we're using, or what the data structure for our frequency might look like. Because I know audio gets very specific. It doesn't just take arrays. Or what the create media element source method does. And it sort of shows this concept that we can start bubbling up logic from these very tiny components into more, I guess, understandable chunks that we can reuse throughout our project. And it's also a very common thing we might want to start using in views. And we're sort of an example of starting to see web component-like things moving in this direction. This is an example of a D3 line graph. And graphs like bicycles are very complex. With a lot of very tiny parts. You'll have your mathematical scales that have to adjust, what your actual data is to how it's represented on the screen. You have your actual line object or your shape object, which creates your SVG, or at least creates the path for your SVG. You've got your data structures, your heights, width. If you want to go farther, you have to introduce scales and possibly some sort of grid overlay, which is more SVG manipulation. Graphing is something that gets very hairy very quickly, and it's another sort of good candidate for this kind of pattern, and a good pattern to have in your toolbox for when you're approaching graphing. I know I've definitely stepped into a lot of pitfalls not knowing about this when I first got into data visualization. But I guess sort of to drive home where things are starting to go, it took very little work to actually turn this into some kind of React component, into one of the frameworks that's starting to gain a lot of traction in the community. And I think it says something that a lot of the developers behind these frameworks have these patterns in mind. And the more time that we spend learning these more abstract object-oriented patterns, the more we can start to understand what they're trying to achieve before we actually get into knee deep into the project we're working on. We can make better decisions as developers and I guess keep ourselves from digging ourselves into more holes. But like anything, there's going to be challenges to challenges and pros and cons to every single one of those objects. sort of think about how applications are structured. But we can also apply that same logic to code, not just graphic design, where our atoms and molecules might end up being like small functions or methods, and we just bubble our way up in complexity. And the challenge with object composition is figuring out where to break off your components. At what point do you break things down so small that it's, you've got nothing but incredibly tiny, hundreds of incredibly tiny things that you just can't piece together in a logical way. Or on the other side of the spectrum, 2,500 line angular directives. Totally not bitter about that. But no, it can go in either direction, and it's sort of something you're going to have to think about if you ever get into learning this kind of pattern. Because at the end of the day, when it comes to our code, we want it to be semantic, functional, and happy, and take functional for either of the definitions, whether it actually works or the functional paradigm. So I guess a quick recap, because a lot of what we've seen wasn't really anything too foreign, but the ideas of what those two patterns are trying to achieve are very different. And with classical inheritance and single inheritance, what we normally think of with object-oriented programming, we end up with things in more of like a tree-like flow of logic. It's really good for things like the animal kingdom or a set of user roles in a database and permissions. It's because it's really good for building off of things, giving you a base to jump off of, and why a lot of frameworks give you single inheritance as a way to create your own things. If you've ever worked on a Rails project, all your models should act like models. This is where that pattern works. But for a lot of the UI work we do, although single inheritance is really, really fantastic, we end up in situations where we want more to work with Legos, and we want to more of just work with an assortment of things and have them work together. And that's sort of where object composition comes in. Rather than building off of something, we want to build with things. Oh, and I don't remember why I put this slide here. So we're going to skip it. So we're going to dig into a little bit of the code. I basically took everything we went over and built a JavaScript audio frequency graph thing. It's an audio player in React and D3. The code is up there, and all of this will be put up online somewhere. And I guess before that, I'll finish off a few more of the slides. Going further, not JavaScript, but this is probably one of the most useful object-oriented design books I've ever read. Especially anyone who's into Ruby, take a look at this book. Practical Object-Oriented Design in Ruby. I read this while working on a very intensive JavaScript project, and it really, really helped in helping me organize my code, especially for some of the more complex application logic heavy things. For your JavaScript guys out there, not quite, I don't think it gets really into some of the stuff I was talking to here, but I always put this book up. JavaScript Design Patterns by Adi Osmani. It's probably a little, not outdated, but more geared toward ES5 patterns. Still a very good read. Surfer not found. No, yeah, I saw. This will be up later. It's a video by ThoughtBot that pretty much put this whole presentation together in 5 minutes and probably explained it better than I did. And for getting in touch, got a website. I have a Twitter handle I'm actually using now, so anything McLean code. And I have an email address that has nothing to do with McLean code. This will all be up later. If you want to get in touch, feel free to talk to me after.
I think we're gonna grab these after. So.
Yeah, or beer. But some code now. Well, I guess actually first to show that I'm not lying. It's. Why is there no audio? This will be up. This isn't local. But as far as code goes, what am I doing on time, by the way? All right. I can find my mouse again. There I am. Hey. Okay. All right, so very similar to what we had in the presentation, just a very simple line graph. Oh, yeah. Yeah, very similar, just a simple line graph. You have your constructor and you have your two methods. Path, which constructs the string of data that builds the SVG area chart that we saw before, and the render method, which React uses to help build the DOM elements. And pretty much all I do is I take in a series of props that get passed to that line graph, and that line graph and then that line graph will use, the mathematical scales and the line object to actually construct that graph. I guess the audio stream is a bit bigger, and there's a little bit more going on here than in the example. But it's pretty much the same idea, where we take in an options object, whether or not the audio is playing, and we take all of the different parts of the audio options, whether it be the audio source or the context. We build new objects to use off of that context object and store them all on the instance of the audio stream. And then we can do some interesting stuff, connecting our analyzer to our destination so we can keep an updated version of the streaming data, toggling the play variable, actually playing and pausing the audio, broadcasting events about the audio stream, and so on and so on. And maybe infer something about the frequency. Maybe we want the average frequency or something like that. But pretty much taking a bunch of tiny things and telling them all to work together to achieve some sort of higher level machine.
Is the frequency the number of times the graph updates?
It is the actual frequency data about the sound.
Is that just an array?
It's I forget the exact, because it's not exactly an array. It's like a unit 8 array. Yeah. Yeah, it's one of those. It's the first time I've ever had to use it. But
PCM or not? That's not if it's PCM or not. It'd be like UN8 or UN16.
It's 8.
Right, so it just gives you like an 8-bit depth, I guess.
Okay.
How many times can it update per second? Like 60?
As fast as it can, because I'm not caring about performance. Because this is a side project. But no, if I wanted to, I can limit it to whatever I want, to some sort of arbitrary frame rate.
Have like an event emitter interface, or how does
It does. There is a node library out there that's just called events, and my audio stream extends event emitter, and I just tell it when it updates, broadcast something so the view can update. Yeah. This is something you might see in some examples on Flux architecture if you ever get into that with JavaScript. I kind of stole it from a lot of those examples. I can go further, but I know that
We can ask questions.
questions are probably better.
Questions on the code at all, guys?
Real quick, what's your username? I can barely read that.
Oh, Havok2905. It's HAVOK 2905. Yep, and this is up on GitHub, so you guys can look through it.
Can you post a link on the GitHub page, maybe?
Yeah. Unless there's any more questions.
Do you accept pull requests?
I do. Actually, I would love to not do any more work on it and just everyone else does stuff to it. That would be fantastic. I like being.
You're gonna regret that.
What actions did you do? Your actions?
The
Did you put the actions in the, just because it's just felt good?
The actions. There are.
The file in the components directory, you have
Yeah.
action visualizer for action.
Oh, that is not actions like you think of as actions. That is the.
Like,
That is the collection of buttons down there. This was. I knew this for the scope of this. I didn't want to go full like Flux architecture. I just wanted a store and a couple of components and update them. I wasn't going too crazy in depth. If I scale it up and I actually do something with it, then maybe. Yep.
I would like to say, your audio stream class looks really well composed.
Boo.
function is 2 to 3 functions and delegates the implementation to the actual object it's containing, hiding the complexity.
Yep.
So I think you did a really good job.
Thank you.
Pretty good composure when you talk.
Oh, oh, thank you. Well,
Did you compose the audio at this point?
hmm?
Did you compose the audio?
You know, I would love to take credit for that, but I would like to not get sued.
All right, we got one more over here.
Oh.
What's the URL for that?
I'm not going to remember that off the top of my head. I think it's just the GitHub.io. Yeah, yeah, it's just the GitHub.io URL. So it's going to be my username, so Havoc2905. Huh?
It's on GitHub.
Put it on Twitter.
It's on GitHub.
It's on GitHub.
I understand, but your handle.
Havoc2905.
We'll have him post
Yeah.
his GitHub link in the comment section of the meetup.
All right, unless there's anything else, thank you for your time.